Today I want to talk about the Poincare algebra, which gives some classifications of the particle into mass and spin. So, first of all, Poincare algebra is the space-time symmetry, which contains space-time translation and rotation and the boost. Large boost is some rotations of the times on the spatial axis. First of all, we can write the space-time interval as a main cosmic space-time matrix as a menu, and it is invariance under the Poincare's group transformation. It should be invariance dr scarce equals to dr prime square. Such as space-time can be transformed by this Poincare transformations, so-called Laurent transformations, the lambda's menu. And if they're adding the additional a mu, that is some transformation, that is a full Poincare's transformation. And from that, we can say that this Laurent transformation satisfy this relation to this space-time is invariance under the such as Laurent transformation. It means that the such Laurent transformations orthogonal to the bottom equals P matrix. Um, uh, Before to discuss about V algebra, to constructs of the Poincare algebra, let's talk about some the more specific examples of the algebra, general linear, special linear, and the orthogonal and unitary group. First of all, general linear matrix, which is determinants is not equal to the juice, and the components are consist with the R, and the embossed matrix is actually the such as sort of the such as matrix is a general linear group. So we can start a general linear groups with the component is complex, and there's the partial is the linear, which is determinant equal to 1. And also we can think about some orthogonal group ones, which is the satisfied orthogonal conditions and is the Weisner matrix with the real components. And as long as it's adding the determinant equals to 1, and so we can consider about the unitary group. You use that as equal to the 1 as U1 and as U1. We can decompose of the such as group or algebra or algebraic structures as a direct sum of irreducible representation, such as with irreducible because it can decompose of the direct sum. And such irreducible representation, definition of irreducible representation is even like that. If the is acting on the VI, which is the VI is inside in the such as the VI subspace is the against in the subspace of VI, such as VI space is called irreducible representations. If such a properties are holds for the any representation V. And if we represent such as subspace in the matrix form, it irreducible representations of the subspace looks like the block diagonal terms form. So now we want to talk about some of the V group and the V algebra. The V groups, there is actually the groups are represent things like the continuous parameters, which depends on the manifolds. And usually the groups has some transformations from as unitary, and it can be expressed as exponential form with the generator. Such a generator is actually Hermitian under some continuous parameters. And the set of the such a generator, Hermitian generators make the V algebra, and the V algebra has some commutative relations of the generators with the structure constants. If the commutative relations of the V algebra is well defined, then the operations of the elements in the Lie groups is well defined. And there are some properties of commutative relations and symmetric, and they should be satisfied the Jacobi's identity. Now we want to discuss about the V algebras one works of the Laurent groups and the Poincare's group. First of all, Lorentz groups issue with the such transformations has a determinant 1, and the lambda geometry components helps with the positive. Such as Lorentz groups called the proper Lorentz groups, which contain the identity, and we will denote the R plus up arrows plus to mean that determinant is the 1, and the arrow is the lambda geometry positive. And the R minus up is actually determinant is equal to the minus 1, which is the parity parity transformations that are minus 1s in the partial components. And then if the lambda geometry is negative, it's actually the charge conjugation, which is the C is the P and T. If we assume that the CPT is conjugate, and if the determinant of the lambda geometry is both are negative, is the term versus which is the minus the 1 and 1 and 1. And we can expand this such as the Lorentz group transformation and the Poincare group transformation near the identities if we consider the proper Lorentz groups. But such a parity, charge conjugation, and atomic versus cannot be expanded near the identity. So we can write the Poincare group as a Lorentz group transformations and the translation part. So it can be parameterized as the capital lambda, which represents Lorentz boost translation, and the A spacetime translation. It is well defined of the inverse and the operations. For example, the inverse of the lambda A is actually the lambda minus 1 minus lambda minus 1i, because you can talk that the representative action nu in terms of the x prime nu, and also we can define the products of the two elements in the Poincare group. Lambda 2a2 times lambda 1a1 is defined like that. If we ask on the lambda 1a1 first for the x nu and the lambda 2a2 as a group transformation, such as the results can be times, and from the Poincare group transformation, there's a covariance the quantity is tensor. If the coordinates are given like that, there are some primes for the transforms widgets, and the axis transforms space-time. Then there's such a tensors with the upper index, down index transform like covariance. For example, upper index mu1, there's a mu1, alpha 1, and alpha 1. And the down index mu1 and beta 1 case, that tensor is the numerator and mu1 is the denominator. So it is upper index called the contravariance. Yes, which is the transforms the like the coordinates, and for the covariance cases that are lower index for the transforms like basis. So for example, this color is the invariance under the Lorentz transformations through Poincare transformations is the color. And also we can define the vectors, which is the only the one open index. And the also we can define the or the two tensors and other three tensors and so on. And maybe this is next sections, and we will discuss about the spinner, which is some other representations of the Poincare groups, because there are some universal couples of the Lorentz groups SR2C, so there's a additional spin representations of the Poincare groups.